Hey guys, so today we're going to look at section 2.4 in your notes. If you want to look in your book as well, you can sometimes. This is on page 25. So some things will reference you right to your notes, right to your book. A lot of things I'll write down things that you could write down, but also look to your book for more things if you want. And some of these I take directly out of there. Okay, so for today, we're going to have two different scenarios. We're going to have what we call infinitely many solutions, and you may have seen that as I.M.S. So infinitely many solutions, or another way to say this one is all real numbers, which has the symbol. You don't need the parentheses. I'm just putting it there to show. It looks like an R with an extra line. This one occurs, infinitely many solutions, when you have a true statement with no variables. Okay, so an example that we'll see in a minute would be like 5 equals 5. So you're going to have at the end, instead of x equals 5, you'd have like 5 equals 5, or negative 3 equals negative 3. The variable is going to be gone, and you're like, well, what's going on here? Just is one of these special scenarios, so it'll mean you have infinitely many solutions. The other opportunity or possibility we have is that it has no solution. Now, the symbol we use for no solution as well is called the empty set. It's a 0 with a line through it. It means nothing works. So infinitely many solutions means everything works. No solution means nothing works. Whatever you plug in, nothing would work. Infinitely many means everything you plug in, it would work. So this is going to be a false statement with no variables. So for example, you'd have 5 equals 0, or negative 7 equals 2. At the end, you're going to get something that does not make any sense. Okay? So when you're solving, nothing changes in the problems that you're solving. How you do it, everything is exactly the same. So I'm going to do a quick one here. 3x plus 5 equals 3x. Okay, slide that down. Away. So if you're looking here, there are no parentheses. We're going through our 5 steps. There are no like terms, because like terms would only be on each individual side. So nothing on that side. 3x and 5 are not like terms. 3x is on its own. Then you get to variables on both sides and you move the smaller. Well, what's smaller, 3x or 3x? Well, they're both the same. So if I look at it either way, I have to subtract because it's a positive 3x. So if I have, I'm going to change my autofocus to see if it stops doing that to you guys. When I do this, then something happens. Magical. This is gone. This drops down to be a 5. Now, a lot of times people will say over here, there's nothing left. You're exactly right. There is nothing left, and we have a number for nothing, and that is 0. So when I look here and say, oh, well, it cancels out, and you say nothing is left, correct. 0 is nothing. I'm done. There's nothing else to do here. I have 5 equals 0. The variable is gone. So when I go back to, I actually have this one quite by random, but it's a false statement with no variable. So my answer is no solution. And you have to write that out for no solution as your answer. Okay? All right. Next one I want to look at. Let's do 4r or 4x. I hate things other than x usually. Minus 2 equals 4x minus 2. Now, some people right here will be like, well, those are exactly the same already. Yep, you're right. And eventually you might be able to say, oh, I know this is infinitely many solutions. So when I look here, you have 4x minus 2, no like terms, no parentheses. Same thing over here. I move the smaller variable, which is 4x. Well, I have negative 2 left here and negative 2 left here. Okay, that is a true statement with no variables left. So because it's a true statement, you could write infinitely many solutions. You could write the all real numbers symbol as well. Okay, This just gives you another option now. When you're solving, you could still get an answer. You could still get what we call one solution, but don't ever write one solution. One solution just means you got an answer, x equals 7, or something to that extent. Okay. Let's take a look at, I'm going to do one more with a bunch of stuff in it. So we have 3 times x plus 1 plus 2x equals 2 times 2x plus 2 plus x. So I got a bunch going on here. I have distribution first because I have parentheses. So I'm going to do that to each side. So I get 3x plus 3. 3 times x is 3x. 3 times 1 is 3. Plus 1 plus 2x. 2 times 2 is 4x. 2 times 2 is just 4, and plus x. Then I check, do I have like terms on each side? Yeah, I have some like terms here. And again, just on the left here, I have 3x and 2x. And I'm going to do them both together, 3 and 1. So 3x plus 2x is 5x. 3 plus 1 is 4. Now, over here, I have 4x. And if you want to put a 1 in there, that's 1x, because I'm just looking at that side. So 4x plus 1x is 5x. And the plus 4 does not have a like term, so it drops down. So from here, some of you may say, oh, they're exactly the same, infinitely many solutions. Okay, you could stop there. This would be enough work for me. I'm going to go one more step and say I have variables on both sides. Let's do the opposite function. So plus 5x turns into minus 5x. I get 4 on this side equals 4 on this side. Again, that is not my answer. My answer is infinitely many solutions. How do I know the difference? This is a true statement with no variables. 5 or 4 does equal 4. Okay, so just real quick summary again. We have 2 other possible answers. Sometimes variables disappear. If the variables disappear and you have a true statement, -2 does in fact equals -2, your answer is infinitely many solutions. If you have variables disappear in a false statement like this, 5 does not equal 0, that is not a true statement, your answer is no solution. Now, just another thing, again, this one I didn't do any steps differently. All it was the end gave me a different possible answer. Okay, have a great Tuesday night, and we will see you guys soon. Later.